we're concerned with how fast is water going to move through a soil. And the first thing that we need to talk about then is hydraulic conductivity. So hydraulic conductivity, the strict definition, is the ease with which water is conducted through a porous material like soil. It really depends on permeability. So permeability in turn depends on pore size and pore connectivity. Pore size we've talked about a little bit already. You can have small pores if you have small grains like over here, and if you have small pores, that means you've got a lot of resistance to flow because of higher friction and lower hydraulic conductivity. Over here, with bigger soil particles like a sand, you've got bigger pores, less friction, less resistance, higher hydraulic conductivity. Water moves more easily through that soil. So we can also see that in this video that you guys have actually seen before. If I can find that right here. When it rains, here we've got a sandy soil. And it rains and water moves really quickly through the larger pores in that soil. Over here you've got a clay loam, small particles, small pores. Water moves much more slowly, lower hydraulic conductivity for a clay than a sand. Okay. So this is just to give you an idea of the range of hydraulic conductivities that you'd see in the units, centimeters per second in this case, so length divided by time. You've got the highest with gravels, then sands, then silts, and the lowest hydraulic conductivity in clays with the smaller pores. But pore size isn't the only thing that matters. Pore connectivity matters. How connected are those pores? So over here, perhaps obviously, low hydraulic conductivity, all the particles are smashed together, there's no pore spaces. Here, though, you've got pretty big pore sizes, but they're not connected, so water can't move through any passageways. Over here, you've got pretty big pores, they're well connected, so you can make a path through that, so water can move downward through that soil. So that's higher hydraulic conductivity there. Okay, so we're kind of talking about two different things. We're talking about porosity and permeability. So porosity being the percent of total volume that is void space, empty, and permeability deals really with the connectedness of those voids, and that's really where what confers the ability of a fluid to move through a soil, is how connected are those voids. Okay, so here's another figure. This is showing you here poorly sorted down on the bottom. That means a mix of particle sizes, or well sorted. That means basically one size of particle. And over here we've got fine particles to coarse particles, and this is showing you the lowest hydraulic conductivity on the bottom here, higher up here, and then also down here, lower to higher. So this would have the lowest hydraulic conductivity, right? Low here and low here. And this would have the highest hydraulic conductivity, high here and high here. But we can talk about that for a minute. Here we've got particles that are all one size, and so you've got pretty good pore spaces there. They're smaller than over here, so hydraulic conductivity is lower than in the coarse soil. But here you've got a range of particle sizes, so some ones that are smaller than these, kind of filling in the pores in that soil. So hydraulic conductivity down here is much lower. You can maybe see that a little more easily here, where you've got coarse soils, pretty big pores, but when you've got smaller particles mixed in, those smaller particles fill up that void space, so lower hydraulic conductivity here than here. Okay, and so maybe you can see that here too. Pore connectivity is you have higher connectivity in a sorted soil, perhaps like over here. If you put in more smaller particles, it fills up pore space, so you've got lower connectivity. Okay, so hydraulic conductivity really has mostly to do with permeability, although it's higher in coarse soils than fine because of the bigger pores, but it's really higher in the unsorted, or in situations where you've got more connected pores. Okay, so that's pretty much it, and then the next video is going to talk about specific discharge. So thanks for watching.